Hello everyone, welcome to Quanta AI Labs. So we started the ComfyUI series. Let's understand the stable diffusion process first. So this is the website from poloclub.github.io. I attached the link in the description. So in this one, you understand this is giving the prompt. And what after the prompt, it goes into the text representation generator, which consists of two things. One is tokenizer. It converts every word into the token. Then text encoder, which changes that word into the numerical representation. Then that numerical representation goes into the image representation refiner, where it the image starts from the noise. For example, we give the noisy image to any model. Okay. And then here we put the guiding scale. Okay. So right now I put the guiding scale of 7. So it guides this thing UNet to change this noise into that text form. Okay. With the using of UNet. This is predicting noise to remove. Okay. So for example, let's close this one and see how the image is created. So in the starting, we give the noisy image, then we increase the steps. For example, we increase the steps. It's slowly converting into the our text which we provided. So this text, this guiding scales which we give, it helps to guide that UNet to create that image, the cat, the prompt image. Okay. So for example, here we wrote a cute and adorable bunny. So we got that one. If I put the guiding scale of 0, what it gives? From noise, it gives some random image. So it is not guiding. The text representation don't have power to guide the image representation refiner. Okay. So we need to put, or if I give 20, so it over exaggerate that image. Okay. So we need to find the threshold number which gives us a good image. Okay. Same thing we do in the ComfyUI. Let's start with the basic workflow. Here first we need a model. So we need load checkpoint. So checkpoint means model here only. Okay. So this is the node-based platform which given by ComfyUI. And here if you see there is a model, if you extend that thing, it gives you some nodes. Okay. That's why it calls node-based system, node-based platform. For example, here is the model. I already downloaded that model. So I show you how you download that in the starting. So some basic model you download from the manager. Okay. For example, click on the model manager. If you search for the checkpoint, you find out some basic models, which is SDXL, SD 1.5. So you can install directly from here. For some other models, if you want something else, you need to go to two websites. One is Civet AI, second is Hugging Face. So in further lecture, we will explore that websites too. First, we understand how we make the workflow like that, how we create the image like that. Okay. So first we have a model. First we need a text. Here we learned about text. Okay. We give the text. So we need clip. So here if we pull out this one, we need clip text encode. Okay. Which give the clip only. And we need two clips here. One is for positive and one is for negative. Negative means what we don't want in our image. For example, right now I use the same prompt. Let me copy this prompt. Let me paste. Okay. Negative we don't give any right now. And if you expand this node after conditioning, it will give you the case sampler. Okay. This will give you the guiding scales and other things. And we connect this one positive and negative. We connect this model to this model, which needs key sampler. Basically, this is the UNet here. Okay, in this one, we see the new UNet part. This is the thing. But we need one empty, noisy image. So what we give? We give a latent image. What latent here is? Empty latent. Okay, this is the SDXL model. So the width and the height we give 1024. This is a standard one for the SDXL model, and 512 by 512 for SD 1.5. Okay, so this is the noisy image we want, empty latent image. Why latent? So we can't work on the pixels because of the computes. Pixels take a lot of computes. That's why we change into the latent space. There are two spaces. One is latent space. You can search on the Google latent space. One is pixel space. So we change this image, this pixel image to latent space, which is the 64 by 64, and we create that image in that latent space. Okay. After that, we need to change that latent into pixel. Basically, we only see the pixel images. Okay. So after latent, we need to decode that one. So we need VAE decode. And that VAE comes from here in the first node. You can connect to this one direct. Then this is the image node. So if you extend, we preview that one. Okay. Now there is some seed controlling after generating steps, CFG, sampler and the sampler, scheduler and the denoising. Okay. So denoising is one. How much did you want each step to denoise? You want higher strength. So there is 0 to 1. Denoise is 0 to 1. With higher the denoising value, for example, here we use 1. This is the maximum we using. So in every step, it reduces the noise from the noisy image and creating the image with the full strength. And the sample and scheduler, there are different sampler. So I attach the link for how to check with the different sampler. CFG is how much you want the prompt to give there. For example, guiding scale, we learn about guiding scale. This is like that only. We guide the prompt, how much prompt involved in that one. Steps is this one, the time step. And third is seed. Seed is the particular number of the image, what we give. Okay. Control after generating, randomize. Every time you can fix also the seed, you can randomize also. You want similar image, you can fix that thing. Or you want every time different image, you can use randomize. Okay, let's run this one. Okay. So first it starts with loading the checkpoint. It takes some time. Then it goes to key sampler after completing these steps, and key sampler running. And we see the image. Okay. So it's generating the image with that prompt. For example, if we increase the steps to 30 and we queue prompt, now key sampler is all. Once a model is loaded, only key sampler is running. Okay. So we have different image, randomize it. For example, I fix this image. I fix this seed. So this seed represent to this image. Okay. For example, I fix that one and I rerun it again. It gives us the different one. Okay. So every time you run, you see the image and you can check the sampler and scheduler. So I will attach one link. You can see the difference in all the scheduler where you use for humans, for use for anime. So the people are using different schedulers or sampler name and the scheduler with respect to that. Okay. This is the first video. We come up with the IP adapters and control net, how to use IP adapter in painting, out painting. So stay with us. If you want any information, comment down below and subscribe our channel.